Today we're going to look at the alpha plus beta phase of a copper and silver phase diagram.
Copper and silver are both metallic, so this is a metallic bonding type where we would then know that there is low pressure and low temperatures, which would lead to high strength and high conductivity because the atoms are surrounded by a sea of electrons.
Silver copper has a face-centered cubic structure. This cubic structure has a high packing factor, making the material very strong, but the properties of the respective metals allow the material to stay very ductile. This means that the metal can be used for a variety of applications.
Let's look at an example of a silver-copper alloy. Sterling silver is a common alloy which is 92.5% silver and 7.5% copper. Once copper is introduced into the pure silver environment, mass transfer occurs and a new microstructure, consisting of alpha and beta phases, develops and causes the new alloyed material to be harder than pure silver. This makes sterling silver a great choice for intricate jewelry because it can be quickly shaped without damaging the material.
This is a phase diagram of silver and copper. It contains an alpha and beta phase. We will look at the area between them, which contains the eutectic point at 779 degrees Celsius and 71.9 weight% of silver and copper. One structure of this phase contains is the eutectic structure, which consists of alternating layers called lamella. Although the crystal structures of silver and copper are FCC, we do not believe there is a way to make this a single crystal.
This is a binary two-component phase, so this phase cannot exist without both alpha and beta present, so it would coexist with those two. Is not a metastable phase, as metastable phases are non-equilibrium phases which do not show up in phase diagrams. In order to see a metastable phase, we would need to look at a continuous cooling transformation diagram.
Practically, silver copper is harder than either of the metals individually and is more structurally stable at higher temperatures. The alloy retains the conductive properties of both metals and resists corrosion, making it particularly useful on printed circuit boards. The alpha-beta phase is desirable when a combination of tensile strength and formability is necessary for application.